What's up, Algebra 2 team? It's Mr. Messner here, talking about everybody's favorite fractions. And now we're going to add and subtract them. Last class we multiplied and divided. Now we're going to add and subtract. And just like if you know how to do operations of fractions with numbers, you should be okay with this. Like, you got to remember the key to adding and subtracting fractions is having a common denominator. We are not adding straight across like we would multiply. You know, just to show you, if I ask you what's 4/3 times 7/3, you multiply straight across, you get 28/9. You try to simplify, divide the top and bottom. It's different. It's kind of like adding x's, and I don't want this to confuse you, but if you have 4 x's and you add 7 x's, what happens? You just combine the amount of x's that you have. You have 11 x's. Well, this is like 4/3. This is like 7/3. We have 11/3. All you got to do is add the numerators, and you don't change the denominator. Okay? Great. If your denominator is common. If you don't have a common denominator, like 2/3 minus 3/4, you need to create one. Now, we can't add. We have to multiply these fractions by versions of one another or by numbers to create common denominators. And this is where we bring up the whole concept of a least common multiple. It's not super important to have a least common multiple as long as the denominator ends up being common. Well, it's like I got thirds and I got fourths. What will they have in common? Well, it's like I can multiply the top and the bottom. Now, this is a version of 1, so you don't change it, and this is 4/6. Well, I can't turn 4 into 6. So this is when we think about multiplying the fractions by the other's denominator. So it's like if I multiply by 4/4, this would create 8/12. But if I multiply this by 3/3, this other one's denominator, this creates 9/12. Now I have a common denominator. So 2/3 turns into 8/12, 3/4 turn into 9/12. If I subtract 9/12 from 8/12, I owe 1/12. Okay? Finding a common denominator by multiplying the other one by the other's denominator. You don't always have to do that. For example, I could multiply this by 2/2. Multiply this by 8/8 and get 6/16 and 8/16, and this would be 12, 13, 14/16. But I realize, oh wait, divide these by 2, I get 7/8. What you realize is we don't need to get to 16ths. We can go to the least common multiple by just keeping this 8 and turning this 2 and making it into an 8. And this is kind of something that we may see later, this idea of keep it simple, don't go and make it overly complicated by multiplying both by the other's denominator. Sometimes just keep it simple. Okay, find a common denominator, add it together. Like 6 and 4. I could multiply by 4 and 6, both sides, so it's like this is 24ths and this is 24ths. But it might be easier to realize, oh, I can multiply this by 2 and this by 3, and I'd get to 12ths. And that is a common denominator. If you multiply it and got 24ths, you can simplify and get 5/12. Okay, so that's your answer. Okay, so common denominators, that's all, common denominators. Well, now we have x's in our fractions, okay? And all we got to worry about is hey, if you have common denominators and you're adding fractions, don't change the denominator. The denominator is already good, okay? Like you have 3, 1/x plus 2's, and you have 4, 1/x plus 2's. What do I have? 7 x plus 2ths, right? Cool. If we subtract negatives, oh, it's the same as adding a positive. and I could have done this before. When you're subtracting, it's the same as adding the opposite. This is very important, thinking about like distributing this negative. It'll be very important in the future. So I have 6x minus fifths, and I'm adding 4x minus fifths. I have 10x minus fifths. Or if I take away negatives, adding positives. Now be careful. I have x plus 2x minus 3s, and I'm subtracting 3x minus 4x minus 3s. Again, we have a common denominator, so we're good. We're not going to change the denominator. We're just going to have to subtract, I'm just going to show this in a big step, 3x minus 4 from x plus 2. I'll show you how to do it a little bit easier. Now, here's the biggest mistake. We are subtracting this entire fraction, which means we are subtracting both 3x and negative 4 from my first fraction. This is where we have to distribute the negative. And this is a big mistake made, and we're going to practice this plenty in class. Don't forget to distribute the negative to every term. Now, again, the denominator is a common denominator. We don't have to worry about it. We can't simplify because of the addition. We're just going to combine our like terms like we would, or x minus 3x is negative 2x. 2 minus negative 4 is 2 plus 4. So this is kind of like the easy way to do it, is just to pay attention to x minus the common term, 2 minus the negative 4. We leave the x minus 3's. Okay, same thing here. 6x plus 3, I have to subtract the x and subtract the negative 4. So I'll have like 6x minus x, and then I'll have 3 minus negative 4. 6x minus x is 5x. 3 minus negative 4 is plus 7. 5x plus 7 over x plus 4. Now, pause. Reminder, you cannot simplify. You cannot cross off the 6 and 3 because of the addition. You cannot cross off the x and the x because of the addition. If it was x times 5x plus 7 and x times x plus 4, yes, these x's could cancel, but I still can't cancel these, okay? So it's a big mistake, and just to remind you, like, we want products, which is why we worked on factoring, and products simplified. Products can simplify. Okay, now we get into the complicated stuff. It appears with 5 over x plus 4 plus 6 over x plus 5 that we are very close to having a common denominator, but we don't have it. It appears that I could take just this 4 and add 1 to it, and I get a common denominator. And maybe you're thinking, oh, I can add 1 to the top and the bottom. But let's just think about it. Could I take 3/4 and just add 1 to the top and the bottom and get something that's the same? No. 3/4 is 0.75. It is not the same as 4/5, which is 0.8. So you cannot add to create common denominators. We are going to have to multiply to create a common denominator. And what we're going to go back to for almost all of our examples is this example when we had 2/3 minus 3/4. We will multiply by the other's denominator. And you could do that here. You can multiply by 2 and multiply by 8. You're going to multiply by the other's denominator for the most part. In almost all of our examples, all of our quiz problems, our test problems, multiply by the other's denominator like we did here. Okay? So what does that look like? The common denominator is actually going to be the product of x plus 4 times x plus 5. I'm going to multiply this by x plus 5 and this by x plus 5. I'm going to multiply this by x plus 4 and x plus 4. Now, here's where we could do some stuff if we wanted to. we could decide to multiply x plus 5 and x plus 4. But I don't want to, because this is like nice and factored. It's x plus 4 and x plus 5. We like to factor all of our fractions so that we have a product. That way, if we could cancel, we'd cancel. But look at the top. If I didn't want to multiply things, I would have like 5 times x plus 5, and then add the common denominator of 6 times x plus 4. I don't like this because of the plus. So what we're going to have to do, and I'm showing like all the steps here, and I'll actually show you like kind of like the shorter way, is we're going to multiply the numerator. We're going to distribute the 5 to the x plus 5, the 6 to the x plus 4, because we're going to be able to simplify the numerator. So let's start with 5x plus 5. This is 5x plus 25. And let's do 6 times x plus 4. That's 6x plus 24. Now, that I multiplied out, but I don't want to multiply this out because this is perfect. This is just like a product. Now, I will combine my like terms. So I get one factor, this 11x plus 39. Keep that, that's one thing, and that's divided by x plus 4 times x plus 5. This is my final answer. You could look to factor the top. Maybe it's a greatest common factor that can be pulled out of 11x and 39. In this case, there's not. You can't simplify anything because you can't cancel this factor with one of these factors. So we're done. Okay? Now, what's the quicker way of doing this? Once you like multiply by the other's denominator, you could just like distribute right now and be like, okay, I got 5x plus 25. And then right now you distribute, you got 6x plus 24. And then you write that added to the common denominator. Boom, you go straight here, and then you combine your like terms. So, again, to create a common denominator, you need to multiply by the other's denominator for the most part. Here, x plus 5 over x plus 5. Here, x plus 2 over x plus 2. But I'm going to go ahead and leave the denominator, x plus 5, x plus 2, and go ahead and distribute the 3 and the 4. So I get 3x plus 15, and I get 4x plus 8. And what I am doing? I'm adding those two things together. Okay? Combining to give me 7x's plus 23. This is one term. There's nothing I could pull out of both of those terms, so we're good. X plus 5, x plus 2's. Done. Now, probably would want to worry about when the denominator equals 0, but we're going to say, like, don't worry about it anymore. Okay, cool. X plus 1, I'm going to give this term an x plus 1, give this term an x minus 4. This would be one that you would like practice in class. Distribute, negative 2x, negative 4 times negative 2 is positive 8, negative 2x plus 8, 3x plus 3. X minus 4, x plus 1. Boom. Negative 2x, positive 3x. 1x plus 11. Done. Okay. Now let's look at another one. 5 plus 1 over x plus 2. 2 over x plus 1. Maybe you should like start with like 5 over like 1/2. Like how do we add 5 1/2? It's like, oh, it's 5 1/2. Well, like 5 2/3. 5 2/3. Sure, right? But like, how to make this one fraction, one combined? We turn this 5 into a 5 over 1. We'll multiply by the other's denominator. Now, like you multiply by 1 over 1 doesn't change it, but multiply this and become 15 thirds. 15 thirds plus 2 thirds, 17 thirds. So write this as 5 over 1. To create a common denominator, multiply this by the denominator x plus 2. Distribute the 5 to be 5x plus 2 over x plus 2. I mean, we can go ahead and make it a common denominator. So 5x plus 2 plus 1 common denominator x plus 2. Now we can go ahead and add the 2 and the 1, and we get 5x plus 3 over x plus 2. Okay, same here. We want to add this to that. Well, turn this into a 3 over 1. Get a common denominator. Multiply by x plus 1, multiply by x plus 1. 2 over x plus 1 plus, distribute this. I mean, I guess I can show both steps. 3x plus 3 over x plus 1. Now add. Well, when we add, we have the common denominator, 2 and 3, 5. I have 3x plus 5, x plus 1s. Don't change the denominators. It's a common denominator. Probably could have skipped that, do 3x plus 3, 2 plus 3x plus 3 over the common denominator, x plus 1. Okay? Now, those are, hopefully fairly straightforward. We got this. But we got to be careful when we're subtracting. Subtraction usually screws up a lot of students, so let's see why. Same process holds. We need a common denominator, and sometimes the easiest way to get it is to multiply by the other's denominator. Okay, I'm going to distribute 3x plus 6, 4x plus 12. But careful, I'm subtracting this entire amount from the 3x plus 6. Maybe this is why we write it as two things. Maybe you can jump straight to the end if you want to. I haven't really figured out what's going to be best for the students yet. Maybe doing this step and then thinking about distributing the negative, or 3x plus 6, 4x plus 12, 3x minus 4x, 6 minus 12. See what makes most sense to students. Regardless, you should get negative 1x minus 6 over x plus 2, x plus 3. Maybe here, if we wanted to, we could factor out a negative 1, creating this simplified fraction, but honestly, that's fine. I'm going to actually change up number 12. I'm sorry for doing this, but I want to put a negative here for a good reason. Okay? So I'm changing up number 12 just because I'm thinking about what's going to happen. I want to make sure you're ready for it. Okay, so again, we need to give this an x minus 4. I need to give this an x minus 4. I'm going to need to give this an x plus 1 and an x plus 1 to create a common denominator. I get negative 1x plus 4. Negative 4 times negative 1. I get negative 2x plus negative 2. I need to subtract those negatives. Just wanted to make sure we had subtracting negatives, because subtracting negatives is adding positives. This is all over the common denominator of x plus 1, x minus 4. Subtracting negatives distribute, or negative 1x minus negative 2x, 4 minus negative 2. Becomes negative 1x plus 2x, which is 1x, 4 plus 2, 6. Okay? Now the next two are just like a little bit more advanced. These are good ones to try. Don't think we're going to have to worry about this for a quiz or a test, like 13, 14, 15, or 16. So maybe we would have something like this. We just got to be careful. We'll see why they're different. What happens? It's still the same start. Got to give these fractions a common denominator. But now when I distribute, I got x times x and I got 2 times x. I'm subtracting 2 times x, 2 times 3. Subtracting the 2x, subtracting the 6, 2x minus 2x, no x's, minus 6, nothing to go with, so I get x squared minus 6 over x plus 2, x plus 3. Cool? Now, throwing this one at you for fun. X minus 4, x minus 4. X plus 1, x plus 1. Common denominator. My common denominator is x minus 4, x plus 1. Subtracting things. But my numerators, x minus 4 times x plus 2. Oh my goodness, I have to FOIL or distribute everything. X squared, negative 4x, 2x, negative 8. Here, x plus 3, x plus 1, x squared, 3x, 1x, 3. Add all of this stuff together, but we're subtracting things. Watch how this is going to work. I got x squared minus 2x minus 8. I'm subtracting all of this stuff. I'm going to use parentheses, or I'm just going to think about like, oh, I'm going to have an x squared minus an x squared. I'll have negative 2x's minus 4x's. I have negative 8 minus 3. I already know what the answer is, but I'm just going to like show you here. This is x squared plus 4x plus 3. So now x squared minus x squared. Boom. X squared minus x squared. Boom. Negative 2x minus 4. Negative 2 minus 4 or negative 2 plus negative 4 is negative 6 x's. Negative 8 minus 3 or negative 8 plus negative 3, distributing that negative, is minus 11. Look at that. It is complicated, but we get a pretty easy answer. Maybe get rid of the negative, factor out the negative 1. All right, again, these two, same deal. This like is more complicated, but like if you notice, like combining a couple of things that we did over the first 2 days with this day, you realize like we don't have to overly complicate it. What have we always done? We've always looked to factor whenever it's possible. Two numbers that add to get 5 and multiply to get 6, 2 and 3. Cool? Well, now look. This already has x plus 3. This is just x plus 2 times x plus 3. A lot of people might be thinking, oh, I should multiply by the other denominator. It's going to be a lot of stuff to do, and you could do this. This is fine. It will work out. You'll just have to factor some stuff out at the end. But like I showed you up here, sometimes we don't want to multiply by the other denominator and to get all the way to 16. Sometimes we can create a common denominator just by multiplying previous ones or just one of them by one thing. So here I can realize that all this term needs is an x plus 2. And then I have x minus 3x plus 6. You can also distribute this negative and do negative 3x and negative 6. It's up to you. And that's a common denominator, x plus 2, x plus 3. X minus 3x is negative 2x. I have negative 6. X plus 2, x plus 3. Heads up. Greatest common factor. Negative 2 pulled out. Woo! It's a beautiful one. Heads up. X plus 3's cancel. Okay? Now, if you want to see how the other way works, and I'm only going to do this example so that we don't run out of time. I'll get the same answer, just creating a common denominator. Okay, negative 2 over x plus 2. I haven't even tried this. I'm going to try it because I know it's going to work. It's math. Okay, ready? I'm going to multiply by the other denominator. All right. I get x squared plus 3x minus 3x squared minus 15x. I'm distributing this negative minus 18. This is over the common denominator, x plus 3 times x squared plus 5x plus 6. All right. I got negative 2x squared, negative 12x's, and negative 18. I'll tell you, you're going to get the right answer, but it's tricky. To factor out a negative 2, this turns into x squared plus 6x plus 9. This is x plus 3. And then I'm going to factor this. This is x plus 2, x plus 3. The x squared plus 6x plus 9. Two numbers that add to get 3 and multiply to get 9 are 3 and 3. So I get negative 2, x plus 3, x plus 3. Over x plus 3 times x plus 2 times x plus 3. What do I realize? That this x plus 3 cancels with this x plus 3. This x plus 3 cancels with this x plus 3. We can, simplify at the end if you wanted to create a common denominator. It works. Just like a little bit more involved, right? Instead, if we factored first, we can find an easier common denominator. We don't have to do as much work, which is why we always look to factor whenever possible. So just to kind of set this one up, what I would do to start is realize that this is x minus 6, x plus 2. I realize they already share an x minus 6. I'm just going to give this an x plus 2, or I'm going to have to do a lot of work. Okay? And might as well finish this off. This is 5x plus 10. 5x minus x is 4x. 10 minus 3 is 7. Common denominator, x plus 2, x plus x minus 6. All right. Now, last part, something I'm not going to spend too much time on. Paying attention to the operation. One last thing we haven't done with these fractions. We had simplifying fractions. We've simplified numbers of fractions. We then multiplied and divided fractions. We now added and subtracted fractions. What's left? Can you solve fractions equal to each other? Now, since we're only giving you simple ones, we don't have to worry about some of the stuff you might do in a more advanced class, a pre-calculus class. What we realize equals, it's not like something we have to worry about as much as subtracting or adding. I don't have to create a common denominator. I'm sure you guys are familiar with our friend, Mr. Butterfly. Yeah, this was the only time that we were allowed to cross multiply. What we can essentially do, and since it's an equation, it has to stay balanced, is kind of create these common denominators. But what happens is instead of creating a common denominator, you multiply this side by the x plus 3 and this side by the x plus 2. You realize it's not necessary. Cross multiply, solve, works. We multiply both sides by the other denominator, and this denominator will go away, this denominator will go away, it'll be brought up. We'll have x plus 2 times 3. We'll have 4 times x plus 3. You guys know how to cross multiply, so let's not worry too much about this part, okay? Use your Mr. Butterfly. Everybody, Miss Bennett in the house. What's up, Miss Bennett?
Howdy,
That's on YouTube for forever. You saying howdy, howdy, howdy. Oh, man. That's why we do this. 3x plus 6 equals 4x plus 12. Subtract 3x. Subtract 12. Subtract 12. Negative 6 equals x. Done. You get into a pre-calculus, we're going to have to do more stuff, okay? We will have to, like, move everything onto one side, set it equal to 0, do analysis, especially for inequalities. But we're not going to worry about it. We're going to keep it simple, stuff that you already know. So pay attention. If you have the equal sign, you can cross multiply, divide. 2x minus 10, 3x minus 12. Make sure you distribute things. One x equals 2. Okay. X plus 2 equals 2x. X is 2. Here, this is a good one. 2x minus 6 equals 2x. X is 0. Negative 6 is 0. Hey, don't forget, sometimes there's equations that are set up that can't be solved. I have 2 over x's. I have 2 over x minus 3's. These will never equal each other. All right, so common denominator, a little bit of arithmetic, simplification. Not as much factoring on this last day, which is good. Previous days, lots of factoring. Possibly is necessary, but common denominators, that's the key. See you on the homework video.